All right. So our objective for today, I can identify polyhedral and compute the volume of three-dimensional figures. What are we doing today, Priscilla? Thank you. So we're continuing on with what we started yesterday. Yesterday, we covered what polyhedral were. We filled a Fourier model with definition. The two different examples that I gave you for polyhedral, we covered prisms and pyramids. You guys remember that? We said that prisms have two exact bases. Pyramids have only one base. For non-examples, we used a cylinder and a cone. And we said that a cylinder and a cone do not have faces or edges. We came up with some hashtags for our critical attributes. And then from there, we moved on to clarify the terminology that we were going to use in regards to face, edges, vertex, and base. We moved on to example number one. Example number one, we said, let's classify it. Let's give it a name. So therefore, first of all, to give it a name, we needed two things. We needed a last name and a first name. The last name is a type of polyhedra. This polyhedra was a pyramid. And then the first name, we use the figure of the base. The base looks like a pentagon. That's why we called it a pentagonal pyramid. You guys remember that, right? From there, we moved on. We did several examples of those. From there, we moved on to volumes. For volumes, I said, we're going to use the general formula of V equals capital V times H. And what does that mean? It says volume equals to the area of the base of whichever figure you're working on times the height. So from there, I gave you three different solids. The first one, a triangular prism, a rectangular, and a cylinder. And I said, for these, identify the base. What figure is the base? And you said, it's a triangle. Therefore, we first, in order to get the volume of this figure, of the entire figure, capital B is the area of the base times the height. Therefore, what is the area of the base? Area equals, we said, base times height divided by 2. That's how we find the area of the triangle. That goes here. From there, they give you a value for the length or the height, and that goes here. And at the end, you multiply that, and whatever it is, units cubed, whatever units they gave you. From there, we look at the next one. We said it's a square. All right, so the square is the same side all the way through, so the area is side times side. Once we get that, that goes there. Multiply times the height, and that's how you get your volume. So, the third one is a circle. To find the area of a circle is pi r squared. How do we get the radius? Well, the radius, we know it's from the center of the circle to the edge of the circle. But some problems on last night's home play, they gave you the diameter, which was a line going all the way across. Well, what do you see? That the radius is what? Half of the diameter. Therefore, find the area of the base first, goes here, multiply times the height there, and that's how you get the volume. Remember those? All right, so with that said, we're going to do a practice one of these, not that one. We did that one in class yesterday, and we did this one, right? So, I want you to write example Q on your blank sheet of paper. All right, so this is what I want you to do. I want you to sketch an oval, because it's a circle sideways, right? It's like tilted. So draw one right there. Draw another one a little bit further down that kind of looks like that one. And then just connect here and here, here and here, and there's your cylinder. Are we there? From there, I'm going to give you the diameter. It goes all the way across. And I want you to label this 12 millimeters, MI, 12 millimeters. And for the height, yeah, then it's not milliliters. I think they made a mistake. Millimeters. The height, 13 and, no, let's make it 10 and a half. 10 and a half millimeters. All right. So, first things first, we write our formula. What is our formula? Volume equals big B times the height. So we need to figure out what? The area of the base. What does the base look like? A circle. So therefore, for this base, I'm going to write area equals pi r squared. Area equals pi times, what is r? The radius, which is half of the diameter, right? What is half of the diameter? 6 squared. Area equals pi times 6 squared, which is 36. So for the area of the base, I'm going to leave it in pi form, so it's going to be 36 pi. And that is in millimeters squared, because it's the area. I only multiplied how many dimensions here? 1, 2 dimensions. Are we there? All right. So let's go to our formula. So we're going to write here, instead of the big B, we're going to write 36 pi. Bring down the volume equals 2 times, what is the height? 10 and a half, so I can write that in decimal form, which is 10.5. Therefore, the volume is 10.5 times 36, and then you can leave it in pi form, millimeters cubed. Find me that number, please. Don't say that out loud. You could hear yourself. Who got 540 pi millimeters cubed? No? I made a mistake? Oh, yeah, it was a big mistake. My bad. My bad. Who got 378 pi millimeters cubed? That is correct. Now, on the home plate, instead of pi, they said to replace pi with what number? 3.14 and round to the nearest tenth. So, for right now, we're going to leave it in pi form so that we can get some practice. Okay? So let's do another one. Here we go. Example, super cube.
What is the chain on the example blank you got?
Yes. Draw your cylinder. There it is.
Asking questions that cannot be answered with a yes or no.
Okay. Here's the radius. So this is 2 feet. And the height, give me a number. 9 feet. Find me the volume of that cylinder, please. Ready, go. Of the cylinder, volume of the cylinder is 36 pi feet cubed. Hands if you got that. Who went the extra step and multiplied times 3.14? Anyone? Julian, what'd you get?
Why am I always the ghost of this room?
No, you're not. 113.04 feet cubed. Hands, have you got that? Very good. Yeah, that's it for you multiply times 3.14. Very good. Yeah. Yeah, so Marcelo was going to ask, Mr. Q, so is it okay if we leave it like this, or do we have to do the extra step? Well, if on the assignment it says use 3.14 for pi, guess what you need to do at the end? Multiply times 3.14. But right now I'm just giving you the process so you can get used to the process. All right, here we go. Let's do another one. Example mega cube. Here we go. I want you to move a little bit to the right, and I want you to sketch a triangle. Whichever triangle that you drew. And then you're going to move to the left of that and a little bit further up, and I want you to make a copy of that triangle that you just drew. Doesn't have to be exactly the same, but try to make it as close as possible. Okay? So now let's connect the vertices. So the top vertex to the top vertex, match it and connect it. The lower one on the left to the lower one on the left, and the one on the right to the one on the right. That one, since it's in the back, make it a dotted line so that we see that it's a transparent prism. There it is. Are we there so far? Okay. Now that we got that, I want you to look at this triangle right here. Tell your neighbor first before I move on what kind of prism this is. Triangular prism, because the two exact bases are the triangle. So check this out. So that means we need the height for one of the triangles. So for the height, I want you to do this. Put a dotted line, and then you need to indicate that it's a height of the triangle by putting a little right angle right here. You guys see the right angle? You guys see what I did? Yeah. All right. Now, I want you to point an arrow to that, and I want you to label it 4 centimeters. The base of that triangle that you drew, I want you to label it 6.3 centimeters. And the length of this prism, or the height of this prism, label it 10 centimeters. All right, so let's find the volume. So we're going to write what? V equals B times height. What do we need to figure out first? The area of the base. So, what is the formula to find the area of this base? Tell your neighbor, please. Alyssa? Melanie? Base times height over 2. That is correct. So then we write area equals, what is the base of that triangle? 6.3 times height, which is 4. All that divided by 2. Area equals whatever that is. You're going to substitute in here. And then you write Z equals whatever that was times, what is the height of the entire prism? 10. Therefore, your volume should be whatever you get in centimeters cubed. Find me that number, please. All right, check with your neighbor, see what they got. See if they have something similar to yours. Okay. What'd you get for this one, Marcelo? 560 centimeters cubed. Hands if you got that. Okay. Okay. Can you correct it, Marcelo, and then give me the correct figure? He's got it. Okay. 56 for the area or 56 for the whole thing? 56 centimeters cubed. Hands if you got that. Okay. Let's try again. First, give me the area of the base. Ryan, what'd you get for the area of the base? 25.2. So this became, let's see, 25, isn't this 25.2 and then divided by 2? Okay, so what is the area of the base, Chris? 12.6, all right? And if you multiply 12.6 times 10, everyone, the volume is? 126 centimeters cubed. Hands if you got that by yourself. Okay, good. Everybody got it? Fairly simple, right? All right. So now that we got these, the only thing that I saw that might have kind of thrown you off was that they introduced complex volumes, such as this next one. For example, look at this barn. This barn, and if they ask us to find the volume, first we need to figure out what two prisms or two polyhedra make up that barn. See if you can see it. Talk it over with your neighbor, see what two polyhedra make up that barn.
I'm sorry, what?
All right, let's see. First thing, who saw that the base of it is a rectangular prism? Yeah, that is correct. A rectangular prism is the base. All right. Also, who saw that the top part is a triangular prism?
Yes.
Yes, that is correct. Which means to find the volume of the barn, we need to first find the volume of the triangular prism, add the volume of the rectangular prism, and that's how you get your total volume. It's like a two-step, yeah, exactly. So you're adding as you go along. Everybody understand? Yes. All right. So since we already know how to do each individual, I'm going to move on for today's lesson. Today's lesson, we're moving on to funner stuff. Here we go. So look up. Today, we're moving on, and we're going to focus today on pyramids and cones. Pyramids and cones. Okay? So now, so that you won't forget, write this formula down for the volume of pyramids and cones. Here it goes. To find the volume of pyramids and cones, we write V equals capital B times H. What do you guys notice? Okay, so it's the same thing, but check this out. Look up. Look up, please. The only difference is this. What do we do at the end? Divide by 3. Now let me show you the why that is. So write your utensils down, look up to the screen. So look, I'm going to focus right now on the rectangular prism. The pyramid. Look at this pyramid. Here's a rectangle as the base. and it's a rectangular pyramid. Well, guess what? This pyramid comes from a rectangular prism. Do you guys see it?
Yeah.
Does it fit inside of the rectangular prism? Yes. And guess what? Anytime you fit a pyramid, rectangular pyramid inside a rectangular prism, it's only 1/3 of its volume. That's why at the end we do what? Divide by 3. Look at the triangular pyramid. Guess what? I'm going to make a triangular what? Prism. That is correct. There it is. And that triangular pyramid is how much of the volume of the prism? 1/3. That is correct. And look at this one. Where do you think the cone comes from? A cylinder. Be nice. Look at it. And what do you notice? That the cone is only 1/3 of the volume of the cylinder. That's why we have to do what at the end? Divide by 3. That is correct. Therefore, let's copy this one. Example 1. We're going to find the volume of this one. Before you copy it like this, let's do it by steps. Look up, please. Follow me. Draw a triangle like I'm doing, like this, and like this. Are we there so far?
Yes.
Okay. Now, for that base, we do need a height, don't we?
Yes.
So let's indicate the height by a dotted line and a little right angle like this. And we're going to label that height 7 centimeters. Okay? The base of the triangle, we're going to label it 4 centimeters. Are we there so far? Okay? Now that we have the base clear as to what you're looking at, does everybody understand what we're looking at? I want you to place a point somewhere over here on top and connect it to the vertices of that base. To this one, and to that one. Now it became a pyramid. You guys see it now? All right? All right, next. Look up, please. This is what I want you to do. I want to create a little 3D image indicating the height from the center of the base all the way to the top, to the vertex. So I want you to place a point here in the center of the base. Make sure you can see it like that. And connect it to the vertex on top with a dotted line. We're indicating the height going through the center of that pyramid. And I want you to show the little 90-degree angle right here so that we know that that's the height. So what is the height of the pyramid? 6 centimeters. Therefore, let's find the volume. What is the formula that we write? V equals big B, or capital B, times H, and at the end, divide by 3. All right? Well, the process is the same. We need to start with what? The area of the base. How do we find the area of this triangle? Tell your neighbor, please. Luke, formula. Over 2. Tell me what you write for B and H. Four times this base, 7 over 2. What is 4 times 7, everyone? 28 divided by 2. What is 28 divided by 2? 14. So that goes right there. So instead of the big B, I'm going to write 14 times. What is the height, everyone? 6, and whatever that is, divided by 3. Find me the volume, please. Volume of that pyramid. Tell your neighbor what you got, see if they have the same thing. Let's see, what you get for this one, Donovan? 28 centimeters cubed. Hands if you got that. That is correct. So what do you notice different from yesterday's? All you have to do is what? One more step, which is divide by 3. That is correct. So your home plate for tonight, here we go. I'm going to give you an Nearpod code. The first picture that you're going to see, look up, is this Michael Jordan, this one on the left, dunking. But here's your code. FGBYU. FGBYU. Now, there's only, you can see 9 problems, but only, I want you to do only numbers 1 through 6. But I included 3 exact slides. So I want you to send me a picture on the first slide of only 2. I want to see the work, so zoom in. You go to the next slide when you send it. I want you to send me the picture of the second 2. And on the last slide, you're going to send me a picture of the last 2. Does that make sense?
Yeah.
All right?
So we're going to send pictures on 3 slides?
Yeah, on 3 slides. Have a good one, guys. Enjoy your home play. Bye. See you guys tomorrow. Bye.